Alright, welcome back guys. We're going to be looking at 6b. So if you recall in 6a we were talking about those measures of central tendency, so working with the mean, median, and mode. And we also saw how outliers could really influence the mean, could really pull it up or pull it down depending on whether those outliers were higher or lower than the rest of the data. But how the median was relatively unaffected by outliers. Okay, and then we also looked at some distributions. We looked at that symmetric distribution, and we talked about a left-skewed or left-tailed distribution and a right-tailed or right-skewed distribution. Okay. And we also talked a little bit about variation, and I defined variation as basically being how spread out the data is. Okay, so now we're going to study that a little more exhaustively. And so to kind of motivate this, let's look right here. We've got hold on just a minute, my computer froze. What we've got here, guys, are two data sets. We've got this first data set, and these are the wait times in minutes at this big bank. And then we have this second data set, which are also wait times, but they correspond to this other bank called Best Bank. And so what we want to do for both of these is we want to calculate both the mean and the median for both of them. Okay, so we already know how to do that. And I actually went ahead and input this data in my calculator. So if you recall, I put the wait times for Big Bank under List 1, and so I'm going to go to Stat and Calculate again, go to One Variable Statistics. I've got List 1 right there. I'm going to calculate, and you can see X bar, which represents the mean, is 7.2. Okay. So the mean is 7.2 minutes, or in other words, the average wait time at Big Bank is 7.2 minutes. Okay. Now I'm going to look back at my calculator to see what the median was. Okay, so remember, if you scroll down here, median is right here. It's 7.2 minutes as well. So interestingly, both the mean and the median coincide. Now we're going to do the same thing with the wait times for Best Bank. So I'll get my calculator. I'm just going to quit this screen. I'll go to Stat. I'll show you real quick. So I put that data in another list. I put it in List 3. Okay, so when I go to Stat and Calculate in One Variable Statistics, I need to put in here List 3. And the easiest way to do this is to come down here where the number 3 key is. You can see List 3 right above it. So I'm going to hit Second and then 3, and it puts List 3 in there. I'm going to calculate. And X bar is also 7.2. So interestingly, the mean wait time at Best Bank is also 7.2 minutes. Now let's see what the median wait time is. It is also 7.2 minutes. So this is very interesting, okay? Of course, you know, this data set has just been constructed for illustrative purposes. But let's think about this. So the mean and the median are basically measures of the center, okay? These are the values about which the data is spread out on both sides, some above, some below, in most cases, okay? Now notice, though, let's look at the histograms down here. Okay, so here's the histogram for Big Bank. You can see it's more spread out, okay? 4 minutes, 5 minutes, so anything that was 4 point or 5 point something, you know, that corresponds to this bar and this bar here. And then these are the frequencies over here, okay, the heights of these bars. Look at Best Bank. Best Bank only had wait times in the 7 to 8 minute range. And if you look at that, or well, it looks like it may actually go like from 6.5 to 7.5, and then from 7.5 to 8.5. That's actually what's happening. So yeah, from 6.5 to basically 8.5, we have all the data in here. So what I want you to take away from this is that these two data sets are completely different. The wait times from Big Bank range anywhere from 4.1 to 11 minutes. And then the wait times for Best Bank range anywhere from 6.6 to 7.8 minutes. So, the mean and the median are both the same, but the variation is different, okay? In fact, the variation for Big Bank is much more than the variation in the data for Best Bank. Because see, for Best Bank, all these values right here are clustered a lot closer to the actual mean. For Big Bank, these values are much farther away on both sides of the actual mean. And you can see this illustrated in this histogram. See how spread out the data is for Big Bank and how concentrated it is for Best Bank, okay? So this is variation, and this is what we're going to be talking about today. How do we measure variation? Now you can clearly see here by these histograms that the variation in the wait times at one bank is a lot greater than the wait times at another bank, but we want to eventually quantify this. So that's what we're going to get to. Now look here. This is an interesting question because it says, based on this information, which bank is better regarding wait times? Well, at first you may think, well, that's hard to say because the average wait time is the same at both of these banks. But when you think about human psychology, this makes a little more sense. I would think that Best Bank has the better wait times. And the reason I say that is because these wait times here are all really close to whatever the average is, okay? And so if you go into a bank expecting to wait 7.2 minutes and you have to wait 11 minutes, you're going to be upset. But if you go into a bank expecting to wait 7.2 minutes and you only have to wait 7.8, no big deal, okay? And so because of the variation, Big Bank is probably going to have more angry customers. And the reason is because it has more values significantly higher than the expected wait time, okay? So that's how I would answer that question. Because, you know, guys, it's all about expectations. Our expectations have a lot in how we have a lot of control on our emotions, how we react emotionally, whether we were expecting something and it did or didn't happen, okay? So anyway, all right, so let's talk about how we can quantify this. Because again, we can clearly see, even by inspecting the data sets, that there's more variation in the wait times at Big Bank. But we want to be able to use a number to describe or quantify the variation in the data, how spread out it is, in other words. And that's what we're going to talk about now. So the first and the easiest way to try to quantify this is by simply listing the range in the data. Okay, and so the range is simply the difference between the highest and the lowest data values. Okay, seems fairly straightforward. So for Big Bank, it had more variation, remember. The range would be the longest wait time was 11 minutes and the shortest was 4.1, so this gives us a range of almost 7 minutes. And then the range for Best Bank, remember, it's the one that had less variation. The longest wait time was 7.8 minutes, and the shortest was 6.6, and that gives us a range of 1.2 minutes. So these two values right here, they in a sense quantify the difference in variation of these two data sets. Okay, you can see this one has at Big Bank, the data has a much larger spread. All right, let's look at this example 1 here. We're going to look at another way or another metric to measure variation. It's a bit more complicated to calculate, but it gives us a lot. It gives us a much truer estimate or value in describing how spread out a data set is, how much variation there is. Because as you'll see in this next example, the range is not really a very good descriptive for, well, it can be, but there are instances in which it cannot be, in which it falls short or is definitely lacking. Okay, and this example 1 is going to highlight this. So it says, consider the following 2 sets of quiz scores for 9 students. Which set has the greater range? And then would you also say that this set has the greatest variation? Okay, so we've got these 2 different sets of quiz scores. So these are our 2 different data sets. So let's calculate the range for each one. So for quiz 1, the range is going to be equal to the highest value, which is 10, minus the lowest value, which is actually 1, and that gives us a range of 9. And then for quiz 2, let's see what the range in the data is. The highest value is 10, and the lowest value is 2. This gives us a range of 8. Now this is why using the range as a metric for describing variation can be deceptive. Because I would say that the variation in the scores is actually greater for quiz 2, because every one of these scores is different. Yet the range is smaller for quiz 2. But for quiz 1, yes, the range is larger, but there's not much variation. All of these scores are 10 except for 1, so there's like one outlier and that's it. So there's actually less variation in the scores for quiz 1 than there are for quiz 2. But according to the range, there's more variation in the scores for quiz 1. So this is an instance in which the range is not a good metric in describing the variation of a data set. Okay, so we're going to look at something more robust here in a little bit. All right, so let's talk about something else. So when we have a data set, we like to use this. It's called a 5-number summary. So it's 5 numbers that describe the data set. One of these we've already talked about, and it is the median. Okay. And by the way, we're going to be using the same data for the wait times from Big Bank as well as Best Bank here. Okay, so we've got these 2 data sets right here for us to reference. All right, so the first thing, is this listed? No, it's not actually listed. Well, the 5-number summary is the lowest value, the lower quartile, which we'll talk about here in a second, the median, the upper quartile, and then the highest value. Okay, so in other words, it's the smallest value in the data set, the largest value in the data set, the median, and then these 2 other numbers referred to as the lower and upper quartile. So let's look at what these are. So the lower quartile, it's also known as the first quartile. What it does is it divides the lowest fourth of the data set from the upper 3/4. It is the median of the data values in the lower half. So remember, in calculating the median, if you were going to do it by hand, you have to put your data in ascending order, and the median is the one that's like right in the middle. Well, if you could take that middle lower piece of the data set and find the median of it, that would be the first quartile, okay? In other words, it's the data value such that you have 25% of the data below and the other 75% above, okay? And then the median, also known as the second quartile, is the overall median. We've talked about this one. It's the value such that you have half of your data set below and the other half above. So basically, the lower quartile, guys, is the 25th percentile. That's what it's also referred to. And the median is actually the 50th percentile, or the halfway point. And then the upper quartile, or the third quartile, it divides the lowest 3/4 of the data from the upper fourth. And it would be the median of the upper half, okay? So if you could take the median and then just take this upper half right here and find the value that's in the middle of it, that would be the upper quartile, or the third quartile, okay? And this value just means that you have 75% of the values below and another 25% above, okay, at or above. So basically, the lower, median, and upper quartiles, they divide the data set into quarters, essentially. This is the first quarter, this is the second quarter, this is the third quarter, and the fourth quarter would be the entire data set. Now, we are not going to calculate the lower and upper quartile by hand. We're going to let the calculator do that. Okay. And so we're actually going to find these. Of course, these values for Big Bank are kind of already given to us, but let's go back to the calculator. The calculator can find these for us. And we've already looked at this. So if you recall, what I already had in here was the statistics for Best Bank. Okay, and so if you scroll down here, it starts giving you what you have right here, guys, is the 5-number summary. The minimum, or the lowest value, here's the maximum, or the highest value. This Q1, this refers to the first quartile. And as you know, this refers to the median, and then Q3 refers to the upper quartile, okay? So the minimum, or the lowest value, is 6.6 minutes. The lower quartile, of course this is pointed to here in your notes, but the lower quartile is 6.7 minutes, okay, right here. The median, well, I remember that was 7.2 minutes. And then the upper quartile, if I look back at my calculator, it's Q3, it's 7.7 minutes. Okay, and then the highest value is 7.8. So you can get this 5-number summary from the calculator. You just have to put in your data set. And then we'll record these for Best Bank as well. They're already shown. So the lowest value is 4.1 minutes. The lower quartile, or the first quartile, is 5.6 minutes. The median is the same at 7.2 minutes. The upper quartile is 8.5 minutes. And then finally, the maximum, or the highest value, the longest waiting time, was 11 minutes. Okay, so that's what the 5-number summary is. And you will have to provide this in your statistics project. Okay. All right, so now let's talk about something else that's related to this 5-number summary. So we have this 5-number summary. We want to show this graphically. And so the way you can do that using those same two data sets is you can make what's called a box plot, or a box and whisker plot. Okay. Now you're not going to have to make one of these for your project, but I do want to talk about it because you do need to have seen it. What happens here? Okay, so here's Best Bank. So here's the box and whisker plot that corresponds to the Best Bank data. And then here's Big Bank. So here's the box and whisker plot that corresponds to the Big Bank data. Okay. Notice this one. The box is right here, and these two tails, these are called whiskers. So think about a cat, okay? You know, it's got its face and it's got its whiskers off to the side. So the whiskers, they go out to both the minimum and the maximum. They extend from the minimum all the way to the maximum. So you'll have a line going from the smallest value all the way to the largest. And lots of times these may also correspond to outliers. And then the box is made up of, the box starts right here at the lower quartile, whatever value that is. Okay, so Q1. And notice my horizontal axis is calibrated in minutes, wait times, in other words. Okay, so the left-hand side of the box corresponds to the lower quartile. The middle, it may not always be in the middle, but this value right here, this is the median. Okay, and then the right-hand side of the box is your upper quartile, or Q3 in other words. Okay, and by looking at this, guys, this will also give you a good way of determining the variation, or how spread out the data is. You can easily see the lowest and the largest value, and then from Q1 to Q3, this is the middle 50%. Okay, it's like from 25 to 75%. So the middle 50% of the data lies right in here. Now look at the box and whisker plot that corresponds to Best Bank. See how much tighter it is? And see how much closer these whiskers are to the actual box? Okay. So the lowest value is 6.6, the highest was 7.8. The first quartile right here was 6.7, the median was 7.2, and the third quartile was 7.7. So just simply by glancing at these two box and whisker plots, you can clearly see that Big Bank had much higher variation in those wait times. Okay, this, and also by looking at these box and whisker plots, you can also tell what the distribution might look like, how it would look like if you were to actually see a histogram. Okay. And like I said, sometimes the median will not be right here in the middle. Sometimes it could be, you know, further to the right or further to the left. It just depends on the data set. And it's possible that one of these whiskers could be a lot longer than the other whisker. Okay, that would just depend on the nature of the outliers. So anyway, these box and whisker plots, these are good graphical ways to represent a data distribution. Okay. Let's see. I think this might be a good place to stop this video, for the part 1 anyway, because now what we're going to do, if you look right here, it says statisticians use the 5-number summary, but often prefer a single number to describe the variation. Now we've looked at the range, but we've also seen how the range can be deceptive. Okay, so we want another number that's more robust. And this single number that we're going to use is something called the standard deviation. Okay, the standard deviation is a measure of how far data values are spread out around the mean of a data set. So that's what we're going to look at in the remainder of this section. Okay, so I think I'm going to go ahead and stop part 1 right here, and we'll finish this up in part 2. And by the way, guys, you are definitely going to want to use your calculator or an app on your phone, or you could also use Excel to find the standard deviation of these data sets, because if not and you're trying to do it by hand, it involves a lot of calculations.